Food is a fundamental human need. We're searching for food since the beginning of humanity, but we have evolved, and with us, our needs have evolved. So we're not looking for food anymore. We're looking for food quality. But what is food quality? Food quality is the taste of a food, its nutritional values, the tradition that goes around food, but most importantly, food quality is related with food safety. Food companies, in order to reassure the quality of their products and thus the safety of their consumers, they have established some tests to prove the absence of contaminants. In order to perform those tests, at first, sampling is done on site to a huge amount of samples, and then transportation into the lab where screening assays and confirmatory analysis is performed to a smaller amount of samples, and finally, the samples that are found positive for the screening of contaminants is less than 1%. As you can imagine, this is a very elaborate procedure. But if that's the case, then why do we still see food-related scandals? In more details, what's happening in the lab, at first, screening assays, such as lateral flow immunoassays, give us a first indication whether a contaminant is present in the sample or not. If you don't know what a lateral flow immunoassay is, it's like a pregnancy test, but instead of measuring the pregnancy hormones, we're detecting food contaminants. A lateral flow immunoassay consists of a control line that shows whether the test is performed correctly or not, and a test line that shows whether the test is positive or negative. Both lines have antibodies on them. An antibody produces a signal when a specific substance is on the sample, and they don't when other substances are there. However, if a substance of the same physicochemical characteristics is in the sample, it might produce also signal. For the positive results of the screening, confirmatory analysis is going to be performed. By measuring the molecular weight of an analyte, it acts as a molecular fingerprint. So we're able to identify the substance that caused the positive signal from the screening. In order to do that, at first, extraction of the substance is performed, and then chromatographic separation and measuring with the mass spectrometer of the molecular weight and the separation. However, this procedure is very time consuming, mostly because of the extraction part, but also because of the chromatographic separation. In FoodSmartphone, we're aiming into taking a different approach by replacing the time-consuming chromatographic separation with an ambient ionization mass spectrometric technique. We will be able to identify the contaminants only based on their molecular weight and not on their separation. In order to replace also the time-consuming extraction, we wish to couple the ambient ionization technique with the lateral flow immunoassay. In this way, we will gain more information from the screening. Instead of knowing only whether a contaminant is present or not, we will also gain information on what is the substance that caused the positive signal. However, instead of having easy to interpret data as we wish, the signal that we get is very complex and very difficult to interpret, mostly because the solutions that are used in lateral flow immunoassays are not compatible with ambient ionization. But if this coupling is performed correctly, then we will be able to provide you with safer food. Hi, I am Ariadne, ESR 12 of the FoodSmartphone project. I want to thank you for listening to my introductory presentation about my contribution in the FoodSmartphone project. I wish after this presentation, you gain more insight about the coupled technique that I'm developing. Stay tuned for further update on the progress of the project, and that's for now.